We are looking now at the theoretical background for problem solving and problem dissolving. We have learned that systems have inherent and emergent properties or qualities or characteristics. Let us first discuss the inherent properties. Those are properties that are embedded in the parts of the system, and their cumulative total is the same as the quality at the level of the whole. So, for example, a typical inherent property is weight. The parts of a system weigh in total the same as the system as a whole. System thinkers like Garchadaki, for example, refer to that as type 1 properties. A finance situation would also be a type 1 property. We have a budget in an organization, and we can divide that between the different functions of the organization. It is governed by win-lose. If one function gets more money, another function has less money, or the number of staff that we can distribute between different functions in the organization. If the one has more staff, then there is less available for the other. Our total staff component is the same as the sum total of the staff of all functions of the organization. So type 1 properties are typically quantifiable, are measurable, and are very often the basis of our analysis of a system like an organization. So if we're evaluating an organization or the success of an organization purely on its financial performance, then we are evaluating it on the basis of a type 1 property. The emergent properties which characterize system thinking arise out of the interaction of the parts. So they are not qualities that are inherent in the parts, but they arise out of interaction, and they are unique to the system as a whole. Love, for example, in a marriage arises out of the interaction of the parties. Or life of the body arises out of the interaction of the different functions of the body, giving rise to what we call life. And that is typically referred to as type 2 properties. And they are those properties we can't easily measure and we can't quantify. Beauty, success, love, happiness, power, hate, positive or negative qualities of that sort are type 2 properties. And very often in an organizational context, we focus too much on a type 1 property, especially finance or in the economy, and we are neglecting type 2 properties. The potential for innovation, for creativity, the accumulated knowledge in an organization, those would all be type 2 properties. We know they make a huge difference, but it's very difficult to evaluate these type of properties on the basis of a type 1 property. It definitely will give a skewed view of the system. Let us now look at the problems of a system. A problem is a quality ascribed to a system, because the system exists, but we say it is faulty or it has a problem. So it is one of the characteristics of the system. And we can again divide it into inherent problems and emergent or systemic problems. Now let us see what are the characteristics of inherent problems. They are objectively given. If I give the example of my car having broken down, any mechanic looking at it will come to the same conclusion why the car has broken down. And it involves typically a single cause or a limited number of causes. So in my case, it may have been the gearbox that is the single cause for the car not driving. And the problem description is a status quo description. Even if the car is breaking down today and I only have it brought to the garage in a week's time, it is still the same status quo situation. It is a car with a broken part. The problem hasn't changed in the course of the week. The behavior of the system is predictable. I know if the gearbox doesn't work, the car doesn't drive. I know if I have a flat tire, the car will be driving, but it will be hopping across uneven ground. The outcome and change of an intervention is controllable. I know exactly what I need to do, where a mechanic knows exactly what he or she needs to do to replace the faulty gearbox, and the outcome of that change intervention is clear: the car will drive again. And the solution can be enforced. I can go to a garage and say, please fix it. And there's a particular procedure to do that. There will be quality controls associated with how it is done. And there will be a boss who says, this is how it's being done, that is when that car is scheduled, and so on. If we are comparing inherent problems with systemic or emergent problems, we see a different picture. An emergent problem is difficult to delineate. Different stakeholders looking at the problem see different aspects of the problem, interpret the problem differently. If we take the example of an education system in a developing country, then whoever looks at the problem will see different aspects of it. The school psychologist will see a different problem to the industry who tries to employ the school leavers, to the Department of Education looking at the school dropout rates or the ability of schools to manage. The different teachers will have different perceptions of what the problem is. So whoever looks at the problem sees a different situation. The economic facets to the education problem, not enough resources maybe. There are political interference of departments or external stakeholders. There can be cultural one, lack of support for education, for example, by parents. There will be technological problems, that there's not enough equipment in schools. There may be ecological problem, that when there is a rainy season, children cannot get to school, or there may be electricity cutouts, schools cannot be heated, or whatever. So there are different perspectives from which to view the problem, and it will reveal different sides of the problem. And there will be different levels. We can look at education at the societal level, and the problem will be defined differently than at the school level of where my children go to school. So different levels describe different aspects or reveal different aspects of the education problem. Systemic problems emerge from the co-production of players within the system, within education in that case. Stakeholders are players from the external environment. For example, the economy or the finance crisis had a lot to do on economic performance of those countries. They had now less money to spend on services such as education. And then there are also co-factors from the inner environment of the players. For example, there may be disease, malnutrition amongst children, disease amongst teachers, which affect the education situation. And then there are problems arising from the education system itself. It may have the wrong curriculum, it may have the wrong administration. So co-production of what we call the education problem. And also, as we look at it over time, it changes, because the different stakeholders and parts of the system and the changes in the environment, outer and inner, interact and in the course of time make a problem usually worse. We have observed that in many education systems in developing countries, how they got worse and worse and worse simply because the status quo interaction gives rise to more and more problems. So any moment in time we look at the system, it has moved on. It looks different than it was before. Not like the problem of the car, which stays the same. The behavior of a systemic problem and all its players is unpredictable. We are dealing here with parts that are impacted on by other parts and react as they see fit. And especially in the social domain, there's a lot of freedom of the different actors. So, for example, the teachers or the administrators may display unpredictable behavior. And if we make a change intervention, the course the change intervention is taking is unpredictable because we don't know how the different players take to that particular change intervention, and the outcome as a result is unpredictable. Solutions cannot be enforced. They require the alignment and the agreement of many different players that are involved in the systemic problem and their willingness to change their behavior. So if we want to have a new education system, maybe based on a new curriculum, new type of administration, we need the willingness of the school administrators, of the teachers, of the pupils, of their parents to go along with those changes, to align those changes and actually behave accordingly. So because of all that unpredictability and that messiness of a systemic problem, it is referred to by some system thinkers as mess. The term mess was created by Eckhoff. He said a systemic problem like education is actually not a problem, it is a system of interacting problems. And it's not only a system of problems that interact from within the system I'm looking at it, but also in interaction with the outer environment, such as the economic situation or political situation of the country, if we talk the education system. Another term that is sometimes used in this context is problematique. Osbekan uses this, and there are other system thinkers who talk about a mess or a problematique or a systemic problem or a system of problems. Those are all terms referring to the same thing. By comparison, if we go back to our inherent problem, those problems are characterized by order. They're relative, orderly. They are not messy problems. The cause is known, the solution is known, and the solution can be enforced. Other characteristics are that if we are solving a problem, an inherent problem, the problem is eliminated, it disappears. Once my gearbox in the car is fixed, the car drives, there is no more problem. In the case of a systemic problem, even if we transform our education system, there will always be new conflict and there will always be new problems because the interacting parts change their interaction over time as they are impacted on by their environment, and that inevitably will give rise to conflict and new problems if the conflict is or the interaction is not managed systemically. So these systemic issues will always be changing in the course of time. In the case of inherent problems, another characteristic is that as we solve the problem, it does not affect the other parts negatively or the system or other system negatively. So if my gearbox gets replaced, it does not affect the functioning of the other parts if it is really fixed according to the design of the car. By comparison, if we are dealing with systemic problems, it is very often the case that the solution in one area creates a problem in another area. A typical example is the school dropouts in education systems in many developing countries. School children do not reach the highest level of education, but very often drop out very early in the system. There's another problem that characterizes many emerging economies, that we have a high amount of educated young people that cannot be absorbed in the economy. So we have an educated youth unemployment problem. Now, the more successful we are in education to get more children to higher levels in the education system, the more problem we have with unemployed youth. So the more youth unemployment we will have. So as system thinkers, we are not saying we should stop educating people so that we don't have the youth unemployment problem. But what we are saying is, if we are looking at an education system, we cannot look at it in isolation. We look at it in the context of other problems, such as the interface with the labor market, and we need to look at if we should not redesign the content and the delivery of the education in such a way that we are producing outputs that can be employed by the economy, or that are able to be self-employed and create their own economic viability. So we cannot problem solve a problem in isolation of its context. A similar case study that we have discussed previously in the context of suboptimization is, if we are solving or focusing on the problem of having not enough market niche, not enough sales, and so on. So if we are driving a solution in marketing sales to increase those, we may create a problem in the delivery and on the production side. So the more we customize for marketing and selling, the more we create problems for production, which requires standardization. And the other way around, if we want to solve lack of efficiencies in production, we may increase standardization, and then we create problems in marketing and sales, which requires customization. The temporal perspective of problem dissolving has to do with the future of the system. In the case of problem solving or fixing the problem, we are using the current logic of the system to restore it to its former functioning, and this implies a current future. So in other words, as I bring my car for repair, it is restored according to the current logic, and the current future of the car is that it drives as it drove before. There may be some variations in current futures, in the sense that maybe the car is already old and the new part doesn't function so well in interaction with the old car, and it's not as smooth as it was before, but essentially it is the current future that I restore the car to. In the case of problem dissolving, we need a system transformation. And this involves changing the logic of how the system and its parts function. And this logic is based on an ideal design of an ideal future. And as the different parts of the system start enacting that future, or start functioning according to the new design, more desirable ideal future will be achieved, and it will be different from the current situation. It functions according to a different logic. Both approaches are useful, obviously in different contexts and at different times. So for example, when we do an organization transformation and we are identifying all the problems in the current organization, we typically get both problems that can be solved and problems that need to be dissolved. So the famous quick wins in change interventions, that happened as soon as one makes a change intervention are those problem-solving issues. The problem dissolving cannot be handled in a quick win situation, but it requires a redesign of a system, informing the different parts of the system what the new logic of functioning is, and the problems only get dissolved as the new system is being implemented. When do we solve and when do we dissolve problems? Sometimes it's very clear when to solve or dissolve. For example, when my car breaks down, I know the problem needs to be solved. Just because my gearbox broke down doesn't involve redesigning my car into a different model. But in social systems, sometimes the line is not so clear-cut. There are, however, characteristics that we can look at. Problem solving in general means that the system functions well, but it experiences suddenly once-off error, mistake. If it becomes more errors, more mistakes, the line begins to blur. If it's a one-time blockage, if it's a one-time breakdown, if it's a very specific once-off malfunctioning of the part, it involves problem solving. However, if these things occur more and more repeatedly, then we are moving into a problem dissolving situation, which is a system that is generally riddled with problems, repeated problems, new problems that occur after interventions, accelerating and compounding problems. If several stakeholders have problems with the system and are dissatisfied or are in conflict with each other, those are situations when we must think of dissolving the problem. And as I said, it can be a gradient between problem solving and problem dissolving. The methods that we use in problem solving or dissolving, the method in problem solving is root cause analysis. We analyze the system, we identify the part that doesn't work, we fix the part, and then we restore the system to its current functioning. The symbol we are using for problem solving is that of a car with the wheel that needs to be fixed. By comparison, a problem dissolving involves ideal system redesign. So the redesign, the new design of the system is based on a new logic. And the symbol we are using for this is the frog's prince symbol. We have the boiling frog at the bottom, which needs to be transformed into an ideal. So the problem needs to be transformed into an ideal according to a higher order logic. And we are using here the fairy tale, the princess kisses the frog and out pops the wonderful prince. So this story is the symbol of transformation. We are taking the frogs and as a symbol for the problem and the prince as a symbol for both the ideal design and the ideal future. Let us summarize the salient points of our theory of problem solving and dissolving. We distinguished inherent from systemic problems, and we said inherent problems can be solved. Solving of inherent problems restores the system to a current future based on the current logic. By comparison, a systemic problem is a mess. It is a system of interacting problems that are very messy. And they usually arise out of the perpetuation of a system's functioning based on a current logic that is not appropriate anymore, and that creates problems. Boiling frogs. And in interaction of boiling frogs with other boiling frogs, more boiling frogs arise. These situations cannot be solved. They need to be dissolved by creating an ideal design that involves a new and higher order logic. And designing such a new ideal design needs systemic frameworks and creativity, for example, systemic brainstorming methodologies. And once we have done an ideal design and it is clear how the systems need to function in a new way, then these systems, its various parts and stakeholders need to change their behavior according to the new design and implement the new design through their behavior. And as they behave in a new way, the system will function in a new way and the old problems will be dissolved.